These two physical parameters on the slide, speed and velocity, will help us estimate the rate or will help us measure the rate of motion. All of you like to watch cricket match, okay? At times when the bowler is bowling, you get that tagline below saying that this person is bowling at a speed of so and so. And how do you think that this is estimated? Because definitely that speed varies. The every pace the bowler takes, that is again different. So how do we calculate it? Different objects will take different amount of time to cover a specific distance. Some of them will move fast, some of them will move slow. So that is why the rate at which that motion is executed on that object is also different. So one way to find out the rate of motion of an object is to find out the distance traveled by an object. This is called as speed. This quantity is referred as speed, where speed is distance covered in specific time, in the given time. So if it is distance, if you remember, distance is the actual path covered by an object, which is a scalar quantity, only magnitude, no direction. Speed is also a scalar quantity. Now look at the formula given in the green box. Speed is equal to distance upon time. Distance is in meters, it's the length, and time is in seconds. So SI unit for speed will be meters per second. Can speed be anytime negative? No, it won't, because distance will never be negative. If you remember, distance can never be negative. It is only positive. And if I say distance is 0, which I mean that object has absolutely not moved. It's not in motion. Okay. So three things to remember about speed. Speed is distance traveled by an object per unit time. Its SI unit is meter per second. It's a scalar quantity and it cannot be negative. It is always positive. Let us now look into the other parameter of measuring rate of motion. Okay, this is called as velocity. To define it in simple words, velocity is also speed, but it is speed with direction. Okay, herein we are specifying the displacement occurred or seen or by an object in a specific direction. So this velocity of an object is a vector quantity. Since it is displacement produced by an object per unit time, it could be positive, negative or 0. Okay, so formula for velocity is given as displacement upon time. Unit will remain meter per second. We have studied what is speed and what is velocity. But many a times when we say object is moving or a particular car moved on the expressway with a speed of 80 kilometers per hour, does it indicate that the car was constantly moving with that speed? No, it is not possible, as most of the objects are in non-uniform motion. Now, if we want to find out what is the rate of their motion, we need to know what is their average speed. Different objects take different amount of time to cover a particular distance. Some will move fast while some will move slow. Also, the rate at which an object moves will be different at different time intervals. And it can be different for different objects also. To quantify all these, we need to know their average speed. So how can we calculate their average speed? Look at the formula that is given on the slide. Average speed is nothing but the total distance upon total time. Which means what was the total distance that object covered S in the amount of time that the object took to cover that distance T. So average speed V is given by the formula S upon T. Similarly, if we want to find out average velocity for an object that is moving in a straight line but at variable speed. If you remember, velocity is related to displacement. We can also measure average velocity. To understand this scenario, let us first consider that an object is moving in a straight line, that is linear motion, but the speed changes. Speed is variable. Means the speed of the object changes. Like say at the start it was something different, in the middle portion it was different, at the end it is different. But the object has moved. There is some displacement that has occurred. Now, this displacement can be used to find out velocity for such an object. Okay, for that we need an arithmetic formula which goes as velocity is arithmetic mean of initial and final velocity. So, average velocity is equal to initial velocity u plus final velocity v divided by 2 because it is arithmetic mean. For both average speed and average velocity, the units remain the same, that is meter per second square. Meter per seconds. Let us try to solve one numerical to find out average speed. Rajdhani non-stop express travels from Mumbai to Delhi covering a distance of 1384 kilometers. Time of departure is 4 p.m. and expected arrival in Delhi is 9 a.m. Can you calculate average speed of the train? Now, every time you solve a numerical, the very first thing that you do is write down whatever is given, what you need to find out, then put in the formula and then plug in the values. So whatever is given right now is total distance. We know the distance is 1384 kilometers. Time 17 hours. If you calculate 4 p.m. to 9 a.m., that would be 17 hours. Okay, now I have the distance in kilometers, I have the time in hours. We know from the previous slide average speed is total distance upon total time. So 1384 divided by 17, that will give me 81.4 kilometers per hour. So average speed of this train Rajdhani non-stop express from Mumbai to Delhi was 81.4 kilometers per hour.